Good morning, everybody. My name is Professor Suborno Bari, and today we're going to be doing some more physics. So today we're going to focus on the proof of centripetal acceleration is v squared over r, because there's a whole nother realm that I haven't explored. And this time we're doing it calculus. I'm telling you, calculus. So, we're just going to skip straight to the lesson for this one. So, for the lesson...
Professor, please keep teaching. I'm just going to check how the sound is, okay?
Okay.
Thank you.
So, let's say I have... No. So... Let's say we have the unit circle. So now let's split it into 4 quadrants. Let's say we take a vector r. No, we take a vector, a position vector, x of t, x with respect to t, by the way, x of t, that had the same magnitude as the radius vector. Note that. So we have a unit circle with a vector x of t stored in it. And let's say the coordinate of x of t is r cosine theta. What r I'm referring to? Well, the r in v squared over r. This one. And r sine theta. So r cosine theta and r sine theta. Alright. So x of t, r cosine theta, r sine theta.
Wait, Professor, one second. Let me just take notes. I think one of my other students didn't take notes from me when I was gone. Okay, he's back.
Alright. Now, r cosine theta, r sine theta. Now, we're going to write the vector x of t. R cosine theta, r sine theta. But what do we do to get from this equation all the way to this equation?
Is there a plan we should write, Professor?
Yes.
Are you going to give me a list of steps I should do?
Yes.
What are we even trying to prove, Professor?
Okay. So we're trying to prove
Thank you.
AC equals v squared over r.
What is AC? Is it like the air conditioner?
What? Did you not learn from the past few centuries that AC means centripetal acceleration?
Oh, okay. Thank
God. Now, AC is v squared over r. Let's try to prove that. Now, I'm going to start by writing up a little plan. So, this plan I'm talking about is we're going to take...
X of t?
We're going to take the derivative of x of t with respect to t. So that will give us v of t, obviously.
Oh,
and then,
because the derivative of position is just velocity?
yeah, didn't we learn that in the first few lectures?
Is it really that easy?
Remember, didn't we learn that in the first few lectures?
Okay.
If you say so. It's truthful. I always tell the truth.
Thank you, Professor.
Okay.
I can always count on my non-discriminatory professor.
As if that wasn't sarcastic. And then we're going to take the magnitude of a of t, and that's going to be our answer.
Wow. So, are we done?
No.
Oh.
We only just started.
Okay.
Okay. Now we have a class of almost 50 students, so stay on track.
Oh, Professor, can you just pause? I think I have a car waiting to pick me up. Okay, yeah, I'm done.
Okay, so we're going to take the derivative with respect to time of x of t. But you may ask, as if you have learned from your linear algebra classes a few hours ago, how can you take the derivative of a vector? I mean, you haven't learned that in linear algebra.
Yeah, vector value functions. Isn't it like we just take the derivative of each component?
Yep. we just take the derivative with respect to time of each component.
Is it really that easy?
Yes, but actually no.
Wow. So far so good, Professor.
Okay.
Okay.
Now we have data here. So we want something in respect to data. So d over d data.
Oh,
But we want to multiply it by something so it equates back to d over dt.
Oh, okay. Can you write bigger? I mean, just so that the people out there can
So d over d theta times, I think that it worked like fractions. So
people can see. Yes, that's much better. Much better.
d over dt
Yeah,
worked kind of like fractions.
Let me just change my my view a little bit, and there we go.
So that means the d of dt of x of t would be equal to d of d theta. I really haven't made quite the height for this. D over d theta, d over d theta,
Oh, Professor,
d
don't
theta.
pass what you write, please. Thank you. I know I keep saying that again. Okay, d over d theta times
And then r cosine theta.
r cosine theta, and then r sine theta, right?
Yeah.
Thank you for writing it so neatly and step by step. I really like to see things step by step because I'm dumb.
Okay, so d over dt of x of t. Oh,
Yes, Professor, sorry, can you keep going?
we have almost 60 students. You must not scream.
Wow, sorry. I just got scared by all the math.
Okay. That almost scared me too. Something scared me.
Yeah.
D over d theta.
Thank you. Wow.
Oh, we have a new student. Yay! Okay. So don't talk, anybody.
Okay, Professor, can you keep explaining?
Okay. So d theta over dt. So I'm going to explain to you that a derivative is just like a tiny nudge in a function, a tiny change. So doesn't that look like delta? And delta theta over delta t.
Oh, that looks a lot like X.
Wrong.
Z.
Oh, omega.
Omega. Oh.
Angular velocity.
Oh, angular velocity. Angular velocity. Yeah, you can keep it.
So now since okay.
Oh, Professor, we have a new student. Do you want to introduce her?
Oh yeah, now we have a toddler as a student. Hi.
Tell her to say hi.
Say hi, everybody.
Go.
Yay! We have a new student. Yay! Anyways, let's get back to the point. R is a constant, so that means it should be factored outside of the derivative. So RW cosine theta.
Wait, Professor. Wait,
RDU.
you just substituted for d theta dt, right?
Mhm.
That's so cool, Professor.
Okay, don't come on camera anymore.
Oh, yeah. Our other student is so excited by the physics. Yeah, so can you keep explaining, Professor?
Okay, now d over d theta is really just the derivative of cosine theta and sine theta. Wow, you have almost 70 students. Anyways, let's get back to the point. So d over d theta, the derivative of cosine theta and sine theta, we have almost 70 students, by the way.
Wow, that's quite amazing, Professor.
And
Do you want me to shift the camera so that they can see all the math?
yeah.
Okay, I shifted it.
So
Can
now
you stand to the side because for a second, just stand to the side.
we have like
Okay. Don't stretch the cable. Be careful.
now
It's a tight space.
we know.
Wait,
Yes,
sorry,
it
what are we
is.
doing again?
Oh, remember we're proving this side.
Okay, but what's part of the plan are we on?
So what part of the plan we're on? Well, we're in the middle of this phase. We're
okay.
taking the derivative with respect to time of x of t.
I see.
We're in the middle of this phase.
Thank you.
Almost at the end of it.
Got it.
So the derivative of cosine theta is actually minus sine theta. And you can see sine theta is actually cosine theta when done by the derivative. So the derivative of cosine theta, this will be useful later on, but the proof of it is absolutely monstrous. So I don't want. So, but if you're curious, you can.
Our new student wants to say hi.
Oh,
Say hi.
Mr. Rodriguez.
Okay.
Mr. Rodriguez, you're back, Mr. Rodriguez.
Anyway, keep explaining, Professor.
Okay, so we're going to get back to the point now. Cosine theta, the derivative of cosine theta is minus sine theta, and the derivative of sine theta is cosine theta.
Oh, can you write d theta, Professor, so we know it's the derivative?
Oh yeah, I'm going to put that in parentheses.
Thank you, that's much
D
better.
over d theta. Yep. Okay. Now, it doesn't look like we have any more space, and the cable is preventing me from going any further. We have a problem.
Oh, Professor, you need some help?
Yeah, I need some more space.
Wait, I'll fix it.
And I don't want to erase the plan.
What's
So,
going on?
I don't have any more space here, so...
I know where you have space. Can you try writing over here?
Okay, but there's not much space there either. So, keep in mind that this will be moved up here for
Okay.
now. Okay. Now,
Okay, so you can just erase. It's okay. You can just erase, Professor.
V of t, we're now at the process of this phase. We're now at the beginning of the second phase.
Right.
So there's like 3 phases to it. We're at the beginning of the second
Professor,
phase.
Sorry, my brain ran out of memory space. Let me just delete some of my own memories.
So you're...
You can't delete your memories.
Oh no.
Why do you want to delete your memories?
Professor, in the meantime, would you like to talk about something?
No thanks. I would like you to catch up with these viewers. Don't leave yet.
Okay.
Okay, we're back.
I'm back in business, Professor.
Okay, we're back in business.
Can you erase some of this? Can I erase this? for you?
Yeah.
I like being the student eraser. Is that okay? Okay. How many students do we have right now?
Around 60.
That's quite a lot, wouldn't you say?
Yeah.
Oh, make sure you don't cross the green line, Professor.
Okay.
Keep
So
going.
now, I want you to understand that we're on the beginning of the second phase. So we now have
No, Professor, don't. Oh, yeah.
Vt is the d over d theta, okay, minus rw sine theta, and then minus rw, and rw cosine.
We just have an overexcited student, Professor.
Yeah, we have a very overexcited student apparently. So let me check if this is right. So we.
Wait, Professor. So,
Oh my God.
sorry about that, Professor. In the meantime, can you explain how you got there?
Okay, so remember we took the derivative of cosine theta with respect to theta. That would give us minus sine theta, so that's why we wrote minus sine theta. And then for sine, it would just give us the exact same thing. Apparently, there's some missing minus here. I'm not sure what to do about that.
Oh, Professor, what do you need help with?
I'm not sure why there's a missing minus here.
Why is there a missing minus there?
Yeah.
What do you mean missing minus?
We'll forget it for now.
Oh, no. No.
Huh?
Remember, the derivative of cosine was negative sine, and the derivative of sine was cosine.
Yeah?
Okay, so far so good. Everything's great, thank you.
So, now we want to... Oh my goodness! Mr. Alex Rodriguez! He's woken up!
No, Professor.
The awakening of Mr. Rodriguez has begun. Okay. Now we're going to take the derivative of v of t with respect to t. Now we can do the same process as we did with the vector x of t.
So, Professor, aren't we going to move on to a of t by taking the derivative in respect
Yep.
to time?
We're somewhere in the middle of the second phase.
Okay. So let's move it.
Move it. Okay. So we want to take the derivative of
So
this.
that's going to be what?
No.
derivative of-
D over d theta times. Okay, so we're adding an extra w, and we're
Okay.
also going to make this cosine.
Right, because derivative of sine is just cosine.
Yeah.
Easy as that. But can you not block what you're writing, Professor?
Oh, and rw cosine theta, we're adding a new squared, and then cosine theta is minus sine theta.
Oh, you see, we got all the negatives.
Yay!
Yeah, please don't block what you write.
Okay, so
Because people are really dying to learn.
I forgot to add the d of dt. Sorry.
Okay, it's okay.
No, it's technically a of t already because I've took d of
Oh,
dt.
that's right. Did you
So
actually already take it, or are you just?
no.
Oh yeah, I think you already took it.
Now we're in the beginning of the third phase.
Oh,
The
okay.
third and final phase. We're almost there, everybody. We're almost there.
Yeah, motivate the people.
Yeah.
The lady.
Oh, lady. Now, we're first going to factor out the minus w squared.
Oh, okay.
Minus
So,
w
If
squared.
we factor out the minus w squared, does that look like something we had before?
Yeah. R cosine theta.
Mhm.
R sine theta.
Whoa, that's crazy.
Isn't that just x of t?
That's just x of t, Professor.
Yeah, but we're not going to do that into x of t. Instead, we're going to take the magnitude of x of t. Because that's what we want.
That's pretty wacky.
So
Professor.
now,
Can
we're
you stop blocking what you're writing, Professor?
So now we're
Go to the
starting.
other side. Right side. Go to the right side.
Okay.
Because you're stretching the mic. Go
Now,
to the right side. Professor.
right side.
You know
Oh,
what right side is?
okay. So now, r cosine theta, r sine theta. So we want the whole square this.
Ah, that looks good. I
And
like whole squares. I don't like half squares. Whole squares are my favorite kind
what
of
are half squares? This man doesn't know his algebra. Now,
algebra, apples, it's all the same to me.
cosine squared theta plus r squared sine squared theta.
Professor, it seems like, yeah.
What? Now we can factor out r squared. And do you see something special? Sine squared theta, cosine squared theta plus sine squared theta is just 1. You probably learned this from your linear algebra class, but yes, this is just 1. So this just leaves us with root r squared,
Professor, you
which is r.
blocking like literally everything you're writing. Which is, there's no point to writing something if people don't see it.
Which means that a is the whole squared of minus w times r.
Whoa.
So you,
W squared R? Whoa. That's crazy, Professor.
do you remember what that is?
Well, I know W is like...
No, remember from the last lecture where we
Oh,
discussed every type of
right,
rotation?
Centripetal acceleration.
Yes, we're getting closer.
Oh my
And
God,
if we want that,
rotation. Enough to be like...
and if we want to simplify it even more, we know that v is omega r, so omega solve for it v over r. So omega squared,
Professor, why did you erase omega is equal to v over r? People need to know that.
omega equals to v over r. There.
Thank you, Professor. I appreciate your cooperation.
Times r. Now these cancel out, and you get the historic equation.
Wow. Thank you, Professor.
And that's the
Oh.
proof. Mr. Rodriguez is awakened. That's a good conclusion to this episode of physics. Bye.